Hello, everyone. I'm Kashif, a PhD student here at Rice, advised by Professor Laura Schaefer. And today I will be talking about our work on enhancing data center energy efficiency using solar thermal boosted waste heat recovery system. So we have all witnessed the rise of technology, especially with the AI rise. And we are at a point where we need more and more computational resources. And as a result, we are building more and more data centers. So as we build more data centers, one thing to note is their electricity demand. And this chart here shows the amount of energy that data centers are consuming worldwide. And during 2022, we already passed Great Britain. And by 2026, we are expected to pass few more countries. And this number can be even higher than this because as we go on daily basis, we are hearing more and more announcements about building these new data centers. So the question rises, where does this energy goes? And we see like significant portion of this energy that's consumed by data centers is lost as waste heat by the cooling mechanism. So that gives us an opportunity to recover some of this waste heat, reuse it for power generation or for heating application. But when it comes to recovering this heat from data centers, what traditionally has been done is using the organic Rankine cycle as a power cycle to recover this heat. These cycles are usually used for low temperature waste heat recovery or power generation scenarios. And what happens is like the fluid that goes out of data center after cooling is passed through the organic Rankine cycle for power generation. The challenges with the traditional methods is like the temperature that comes out of the data center is usually very low for org to operate efficiently. And as a result, we get lower thermal efficiency, which results in higher cost of electricity. So what we propose is like having the same two-part setup and adding the solar field in between, which is the solar thermal collectors. So what this does is like during daytime, the fluid that goes out of the data center is passed through these solar thermal collectors, where they get a significant temperature boost. And as a result, you get a higher org efficiency, which is the same equipment that you already had. So as a result, your temperature boost will provide higher thermal efficiency, and your cost will go down. So to investigate this further, from techno-economics perspective, we did two case studies, one in Ashburn, Virginia, and the other one in Los Angeles, California. And both of them are famous for their number of data centers. And the results show that if you look at the figure on the left, it shows the daily variation of thermal efficiency during all 4 seasons. And the efficiency stays same in both cases when we don't have sun. And as you can see, during the middle of the day, when the sun is shining and we get solar resource, the efficiency is significantly boosted. And similarly, the figure on the right side shows the annual variation of the thermal efficiency. The green is the traditional way when you don't have the solar thermal part in, and the purple shows what happens when you add the solar thermal part. And each cycle during the day when you have those solar hours, you get higher thermal efficiency. So this is what we wanted to achieve, but what happens in terms of numbers of powers and cost? So we see that during peak solar hours, we can increase the efficiency by up to 8%. And as a result, the power output was found to be increased by 73% in Ashburn and approximately 100% in Los Angeles, California. Again, the main idea behind this comes to the cost deciding factor. And we found that the cost is decreased by 8.6% in Ashburn. That's the per unit cost of electricity. And it was decreased by 20.11% in Los Angeles, California. The main difference between these numbers for both sides is the solar resource and the number of solar hours that you get in the day. LA, of course, has the higher number in that case. So these findings show that in adding solar thermal not only increases the energy efficiency of data centers, but by introducing renewables into this, we also increase the energy sustainability of data centers. Thank you.